Okay, today is going to wrap up the final part in terms of how do you work on vector diagrams. So, we're going to operate on the principle that you are aware that when you are working with vector diagrams, and we're on this page right here, it's the blank page. You should have the previous page. You should have all of your work done and all your answers labeled. And we're on this page right here. So again, we're operating on the idea that you have gone over your vector diagrams. You're able to identify what the vector components are from the resultant vector. Starting out, you're always going to label up your diagram. Always. Take a moment. It's going to save you so much time and effort. So much frustration is going to be eliminated because you'll have spent a couple moments labeling things. So we have our starting point. How do I know that that's my starting point? Well, that's where my angle is. So if that's where my angle is, that's where my starting point of my resultant vector is going to be. This resultant vector is going to be pointing to the bottom right here. It's going to be towards the southwest. That means that the 10 is going to be labeled as my hypotenuse. Now you might ask, well, how do you know that it's the 10? Why can't it be the one going across like this? Well, if the resultant vector is this one right here, and I think everybody would be all right with understanding that that's pointing to the southwest, just by you saying that that thing is pointing to the southwest, you have two components that are involved with that motion, moving to the southwest. You have one component that's pointing to the west. That's the thing that's at the top. You have one component that's towards the south. That's this thing right here. Those two components make up your resultant vector. All right, you would never, no one is ever going to say, we'll change the color here. No one is going to ever say, you'd be talking nonsense. If the green vector right here, no one is ever going to say that that green component, we know that that's pointing to the west, that the green component is made up of the southwest. If it's just the green arrow, it's just to the west. It's not to the southwest, it's just to the west. That's it. Okay, so we know the resultant vector is going to be a combination of two other vectors, and we're going to have those two other components labeled in our direction. All right. So again, we're operating under that assumption that you know how to label your diagram. We have the first side already labeled up. That's the hypotenuse. The next side that we have labeled from the starting point, that angle theta, the opposite side to it is the 4. Okay. Now this is going to be a little different than yesterday's because yesterday you had been given the angle and you had to find one of the components that make up your resultant. But now all of a sudden you're not given the angle, you're just given what the two of your sides of your vector diagram actually are. You're given the 4, you're given the 10, and now you have to go backwards to find out your angle. So we need to figure out which trigonomic function first has those values. So we're going to look at some SOHCAHTOA here. Problem that some people have, I'm not sure which trigonomic function to use. Don't overthink it. If you spent the time labeling up your sides, we know that one of your sides is the hypotenuse and one of the sides is your opposite side. Now, O and H, tangent has O and A, it can't be that because you don't have OA, you have OH. Okay, you have cosine has A and H, can't be that because you have O and H. So by process of elimination, you have the O, that's the opposite side, hypotenuse, Sine is the one that we're going to use for this. Now, when you work out the problem, we say sine theta. Now, you might want to hold off on writing this down just yet. Okay, you say sine theta. We don't know what the angle is, so I put the theta in there. Equals opposite 4 divided by 10. Now, what's going to happen with some people, you're going to be so eager just to get the thing done. Just move on, just move on. And you're going to say, okay, well, I'm going to take 4 divided by 10, and my answer is 0.4. Thing is, that doesn't look like a 0.4 degree angle for that. See what that 0.4 is? That's the trigonomic value for your angle. All right, that's not the angle. That's the decimal number associated to sine theta. So how do you get from that decimal value, how do you get the actual angle? Well, it's called the inverse sine. You do just the opposite of finding the angle. You're going to find, instead of you trying to find the decimal value, you're going to try to find the angle from the decimal value. So how do you do this? Well, we're going to take and find theta. And normally, let's say you wanted to try to get the 10 to the other side, you do just the opposite operation. Instead of dividing by 10, you'd multiply by 10. So if we're trying to get rid of the sine, the opposite of sine would be the inverse sine. Okay, so it's going to be inverse sine, and we're going to have 4 divided by 10 like this. So on your calculator, how do you get this inverse sine? On yours, you're going to have to get used to your calculators. Some of them have the second button. Some of them are actually going to have inverse sine on there already labeled. But on mine, I have to press the shift. On yours, I think you have probably, like I said, the second button. Okay. We have inverse sine. We get the parentheses. We go 4 divided by 10. And again, you have to get used to your own calculators. On mine, I have to close this. I hit equals. So theta, in this case, is going to be 23.6 degrees is what it's going to be. All right, we'll do 2 more to make sure that you have the basic understanding. And I'm going to use letter B as the example because this is going to be a different trigonomic function for this one. So we'll look at B. Always start by labeling your diagram. So I'm going to have my angle down here. That's my starting point. The resultant vector is going to follow the longest side. That's going to be the hypotenuse. The opposite side of the theta, our starting point, is going to be labeled. So that means that the 3 is the adjacent side. All right, now we have to figure out which trigonomic function we're going to use. So I'm going to put my list up here. And answering which one I'm going to use is already taken care of because I labeled my diagram, unless I just delete it. Okay, so we're going to highlight the H because I labeled it with hypotenuse, and I'm going to highlight the A because I labeled it adjacent. It's already there for you. Going through the list, sine has opposite hypotenuse. Those things don't match up with what I've got highlighted from the diagram, so it can't be sine. I go over one more. I have adjacent, I have hypotenuse, and sure enough, hypotenuse, hypotenuse, adjacent, adjacent, that matches up. So cosine's the winner. Okay, we're going to show the work. And I'll do the long method one more time, and then we're going to simplify this thing to where we're just using the actual work to solve for our answer. So you have cosine theta equals, you'd have the adjacent side is 3, the hypotenuse is 8, but we don't want the decimal value. Right now, we divide 3 by 8, you're going to get a decimal value, and it's not the angle. That's the trigonomic value. That's the decimal value associated with cosine theta. So how do you get the angle just by itself? We have to get the inverse cosine for this. So it's going to be cosine -1. We're going to go 3 divided by 8 like this. So on that calculator now, just a reminder, how do you get the inverse cosine? You're either going to have to press the shift button or the second button. So that way your calculator reads cosine -1 or inverse cosine. We'll go 3 divided by 10. Oh, not 10. 3 divided by 8. Hit enter. So that is going to be, theta is going to be a, in this case, let's just round this thing off to be 68 degrees because if we round off to the first place pass, it's going to change it all. So we'll just say 68 degrees. And to me, that looks like this angle right here could be a 68-degree angle. Okay. All right, we have one more that we're going to do as a group, and then I'm going to turn you loose. So let's see if I can find, yeah, J. Let's look at J as our last one. So J, first thing always, label the diagram. Save yourself the frustration. Just take a moment, label it. If my starting point is down at the bottom for the vector diagram, the longest side is going to be my resultant, and that's always going to be the hypotenuse. From that angle, from that starting point, the 1.5 would be considered the opposite side, and then the 0.6 is going to be labeled as the adjacent. Looking at our list of trigonomic functions, which one do we use? Well, as always, if you labeled your work, you just saved yourself a lot of frustration because you have O and A that's on there. Now, going through the list, OH, I know what you might be thinking, right? IO. Okay, so you have OH, that doesn't match up with what's given to you. You go to cosine. Cosine is AH. Those two don't match up either. So you go to the last one, tangent. You have O and A. Those two match up with what's given to you. You have adjacent, adjacent. You have opposite, opposite. So tangent is the one that we're going to use. Now I said that we're just going to do the work. We're not going to do the long method of writing out tangent theta. So how do you work it backwards? If we're trying to find theta, we're going to go inverse tangent. We have opposite side, 1.5, divided by the adjacent side, 0.6. Okay. How did I know I was supposed to put the opposite side up top? It's right here. Opposite divided by adjacent, opposite divided by adjacent. So calculator time. We'll start this up and clear that off. We're going to go shift or second button. Tan -1 is what should be on your calculator. Inverse tangent. We'll have 1.5 divided by 0.6. Hit enter. And you're going to end up with a 68.2 degree angle for theta. So my resultant vector would be acting at a 68.2 degree angle from, let's say this one, just to make it a little different, from the horizontal. So it'd be 68.2 degrees off of the horizontal. Okay. Now what you have for the rest of the period, we're going to do the exact same thing for the rest of these. So you have A through Q here to work on. And what you're going to find is that once you have picked up on how to do these, it's going to happen very fast for you. Okay. So when you're done, okay, all your work needs to be shown something like this right here. And Then on this last page, I'm going to say for this page right here, I know it's going to seem like a lot of work, but I'm telling you that once you start on the questions here, they're going to be done extremely fast. All right, so for tomorrow, have that page finished up, and then A through H, it's just a variation. It's not just the angle that you're trying to find, or just the missing component you're trying to find. It's whatever is missing. So here you're missing that, you're missing this, you're missing that. So for A through H on this page, do that one also. Now, if you're really good at this stuff, eventually you're going to have to do this whole page right here. Okay, so if you are bored, you want to do the rest of them, go for it. Okay? That's it. Go ahead and get to work.